play a game. I'll describe a major scientific discovery, and you try to guess what it is. Ready? Okay. This thing spans throughout all of space, is fundamental to our existence, and was only discovered within the last decade. Any guesses? If you guess the Higgs field, then you'd be right. If not, then let me explain. The basic building blocks of the universe are known as elementary particles. These are the electrons that help make up the atom, or photons that are responsible for light. And for a long time, scientists had no idea why some of these were massive and others massless. But what even is mass? No, not weight. Mass, which is something's resistance to acceleration when a force is acting upon it. So if something is said to be massless, then it will travel at the speed of light because it feels no resistance. So then the question remains, what is giving elementary particles this resistance? This is where the Higgs field comes in. All throughout space is an invisible field known as the Higgs field, which is responsible for elementary particles having mass. Here's how it works. This rock and sponge will represent two different elementary particles. If there were no Higgs field, they would both travel at the speed of light. But watch what happens when we add the Higgs field represented by this tank of water. As the rock moves through the water, it is barely affected and moves swiftly, while the sponge moves slower and appears more massive. This is not because the field is creating some sort of friction, but rather how the particles themselves interact with the field. If you had three of the exact same racers, they would tie, but change how much they interact with the ground and it's a completely different story. The racer on all fours interacts the most with the ground and faces more resistance to change in accelerations than the others who aren't interacting with the ground as much. Similar to how even though the masses of elementary particles should be all the same, the different degrees in which they interact with the Higgs field determines how much mass or resistance they feel. The more a particle interacts with the field, the more mass it will have. If a particle has no interaction with the field, then it will be massless. But how does one prove an invisible field exists? It was understood that if this field existed, then it had to have an associated particle, the Higgs particle. And it wasn't until they built the world's largest particle accelerator that they were able to detect it and prove the Higgs field. It's important to note that only about 1% of all visible mass comes from the Higgs field. But without the Higgs field giving elementary particles their mass, they'd be flying around at the speed of light, unable to form atoms, and life as we know it wouldn't exist.